Alright, let's look at an example of integration with definite integrals. Let's say that I have the problem, the integral of 2x times the square root of x dx. And the bounds of my integration are going to be from 4 to 9. Alright, so the first thing I'm going to do is I'm going to rewrite this problem, because when we do integrals it's easier to see things with exponential powers rather than roots. So I'm going to rewrite this as equal to the integral from 4 to 9 of 2x, and then instead of the square root of x, I'm going to say that that is times x to the 1/2 power. Alright, now if I try to take the integral from here, I'm not really going to get anything nice because I have two separate x terms here. So what we're going to do is we're going to combine them together into one to make the integration a lot simpler. So this is the integral 4 to 9 again of 2. And then I know that an x by itself really has the power of 1. So when I multiply these two together, since they have the same base of x, I'm going to add their powers. So 1 plus 1/2 is going to get me an x to the 3/2 dx. And then from here, we're going to evaluate our integral. But before we do that, notice I have my 2 here, which is going to come outside of the integral. So 4, 9, and then this is just x cubed, oops, not x cubed, x to the 3/2 dx. So from here we're going to take the integral. And what separates a definite integral from an indefinite integral is that there's going to be no more plus c on the end for an arbitrary constant. We're given these two bounds of x that we're going to apply to the problem. So let's see how we're going to do that. It's going to equal 2, I'm going to say times, I'll make a little bracket here. So taking the integral of x to the 3/2 is going to become x to the 5/2, and then dividing by 5/2 is the same thing as multiplying by 2/5. And then we'll be applying a 9 and a 4. So then for my next step, using the fundamental theorem of calculus, I'm going to plug in a 9 for my x value, and then plug in a 4 for my x value, and I'm going to subtract the 2. So this is going to be 2 times, let's say 2/5 times 9 to the 5/2 minus 2/5 times 4 to the 5/2. Alright, so then from here, we're going to have our 2 on the outside, multiplied by 2/5 times 9 to the 5/2 is the same thing as 243. And then we subtract 2/5 times 4 to the 5/2 is 32. So 32. And then we'll simplify these, and then we'll have our answer. We'll have 2 times, let's see, this is going to be 486 over 5 minus 64 over 5, which is going to equal 844 over 5.